Hey all, this playlist will be focusing on MCP, which stands for Model Context Protocol, and there are tons of videos on YouTube that tells you what are the basic functionality and how you can connect an MCP server with your cursor or cloud desktop. But in this playlist, we'll be going one step ahead. We'll be implementing an agent-to-agent procedure, which will demonstrate how an agent interact with another agent and how this functionality can be achieved using Model Context Protocol. So what all things we'll be covering is like in the first video, which is this one, we'll be simply covering about creation of a basic server. We'll understand the three modes in which MCP works. And going further into playlist, we'll see how these modes are interoperable and how we can deploy one mode using another and vice versa. And at the end, we'll be bringing up a use case so that we can see how agent to agent can be implemented or can be demonstrated in a way through MCP. So yeah, let's just get into model context protocol and we'll start simply by understanding the basics of it. And it will be pretty short and then we will dive right into the code part. So let's start by understanding what model context protocol actually is and what it does under the hood. In this slide, I have provided a lot of information about the internal working, which we won't be needing, but it's just for reference point of view. So yeah, let's dive into the topic of MCP now. So what topics we'll be covering is overview, architecture, building agent, and integration with cursor. This is for this particular playlist only. The overview, architecture, these are theoretical one, and then building agent and integration with the cursor are more related with the code side. So these two are the basics of as an MCP, which I took from their documentation only. So we gave a lot of example of this USB-C port for AI application. So in an if I oversimplify the concept of MCP, so basically it's an API. So in API you have a certain response format, and then there is a certain format in which you'll request for the data, and there is a certain format in which you will get the response. So that's what MCP does. Because typically before MCP, what we used to have are orchestration services, which, so for example, there is an AI agent I'm calling, let's say any LLM, for example, GPT, and you are building an AI application. So AI agent and application, these have a certain understanding that these data should come in this particular format. And for that, we place an orchestration service so that if your LLM changes also, the orchestration service can format the data in which our desktop app or whatever agent we're building is expecting the data to be. So that orchestration service, it's basically handled with MCP. So it just eliminate that orchestration service part. It provide you a uniform way to access for AI agents to access the data that is given by the client. So the most important point is a standardized way. And then why MCP tool data standardization. This is the first thing that was there mentioned in the documentation. So tool data standardization is for example, GPT or Gemini, they have a field called tools. So I just assume we are having some basic understanding of LLM agents. So to run those tool, I mean to give you a better answer, what LLM used to have is a tool that will call certain function, and on the basis of the response or the context which they get from the function, they will answer that particular query. So it standardizes. It means that a code which is written for specifically for Gemini would also work with OpenAI or GPT models or Claude models. So that's what it basically means on an overview. So this is the architecture. So MCP host could be, for example, suppose I'm building an agent in VS Code or let's say on Cursor code editor. So what it does, it's that agent has some, that particular agent, whatever code I'm writing, that is our host application. Now it can create multiple clients in it. I mean, there will be one client which will be interacting with server one, and there will be another client which will interacting with server two, and then three, so on. These could be cross interaction as well, but yeah, one-to-one connection is what we are using for simplified. So uh, this is the pretty much basic architecture. So these servers are what we call as MCP servers, and the data which they produce are consumed by MCP client. MCP client will generally have an agent running with it. For example, this might be running a Gemini agent. This might be running and Claude. This might be running what you say GPT, and all these can interact with this particular servers, and they can get their data, and then they can get their job done. So pretty much this API response is coming back. Then let's talk about two of the functions which are layer and primitive. So primitives means the basics, I mean the fundamentals what the MCP provides, and layers are the way in which MCP allows us to interact with AI agent flow and back. So we have a data layer. So at the core, it uses JSON RPC. So JSON RPC is a different thing from what we have a simple, request response structure. So in JSON RPC, we don't specify about anything like get, post, put. Generally, I mean, in simple word, every request is a post request in JSON RPC. That's not a true analogy, but yeah. So JSON RPC, if we have some background of blockchain, so their JSON RPC structure is used to handle events. For example, if there is certain events happening in the blockchain, it will emit out. If there are certain actions happening, for example, a block is getting created, it will emit out an event which an application can capture, and then it can see all the data, what all things are going on in the blockchain. So just an analogy. So I can show this, but again, it won't be required for us to understand whatever things are going on here. So let's just leave it for the reference point of view. The second is transport layer. So MCP has three modes currently. One is an streamable HTTP, one is SSE events, and then the other is STDIO mode. STDIO mode is basically like you are running some server locally on your system, and then you are using it to interact with whatever functionality the server is having. It's like a Docker file. Docker file, I mean, you pull a Docker file, you are running Docker image locally, and then you can interact, do all sort of interactions with that Docker file, and then you can verify that yeah, this is working fine or not. Then we come to streamable HTTP. Streamable HTTP provides us the concept of remote server. So this particular file, if the server is written in a streamable HTTP format, so what can happen is like I can host this particular server anywhere on cloud, and then multiple machines will be able to access the particular server. So this is something like you can say hosting your backend onto some AWS service. Then we have three things which are native, I mean, which are primitive to MCP, that are tool, resources, and prompt. So tools are basically those functions which perform certain action. I mean, like there can be a tool which will get all the actor name from a data. So whenever any agent will call this particular tool, this tool will read the database, perform certain queries, and then return all the actor names which is coming out from the data, just for an example. Resources could be something like to list out what are things are available within your system, and then prompt are something which can be, it can be considered as a template. So you can have a prompt that says that customized meeting details for this particular person. So prompts are basically templates. The most important one which MCP is used for is tools. And then we have certain notification too that are inbuilt here. So for example, we can set a notification that whenever the server is accessing the database, just send a notification back. So you can capture those notification in the client and show progress. For example, yeah, the progress bar could be a very good example of notification. So you can get an update what's happening in the MCP tool, and that update you can show on your front end, so that if the tool is taking longer to execute, the user will have a UI to see, okay, this much is the progress, this much is the progress. So for that, we can use notifications which are built in JSON RPC again. So yeah, these are the pretty basics overview of MCP. I mean, we won't be diving much into theoretical part, because theoretical part is pretty much more like what do you say, the request response structure of API is what we have. So if you have an idea of API, how it works, you are pretty much will be very comfortable with MCP, because at the end we'll be building a fast API only, and then we'll be converting that into a server. Uh, so let's start building the MCP server, and then we'll start by creating a fast API. We'll take a random example just to show how it all integrates, and then we can move ahead with the custom examples of agent to agent calls. So yeah, let's dive into code and see how it works. So let's now begin exploring the code, whatever we have written. So this is our simple MCP server. Uh, it has three tools currently. So three tools, these are pretty basic ones. So I'll just show you. So in any MCP server, if you see a decorator called @mcp.tool, that particular function is gonna be a tool. Simple as that. typically, if you're writing a fast API, this should be something like not something like what you can say at the rate app dot get, and then you define your path parameter, and then below that you write that current time. So whatever your fast API is, you have to figure out which endpoint can be used as tool and which endpoint can be used as resource, and then you just have to use this particular decorator. It's simple as that. So what MCP.tool does is like, so there are three things to consider. So the particular thing is like in this at the rate MCP.tool, I can define what its input parameters will be, what its output, how it's gonna give its output, and what will be the description. So description part is important. So if I write something like description, so whenever your LLM, I mean any AI agent is trying to figure out which tool it has to call to answer a relevant query, it focuses on description, it focuses on input. These two things is what the agent used to determine which tool to call. So, for example, this particular tool has a definition of get current time, and in description I have written get current date and time, so it's pretty much synchronous. But if I change the description to something like get weather, so at certain point of time your agent might hallucinate to call the get current time when the user is asking about weather. So that's why these things are a bit important. We can understand it as a prompt only. Let's just not use description for now because we won't be calling any tool. We'll be just simply using it. So I have this particular tool, then I have a calculate tool just random to show that it can get arguments from the client and then perform operations on that. And then this is search user, so pretty much basics of it. Uh, let's then see, this is a resource. So this is how a resource looks like. Resources do not perform any operation in general. They are lightweight. I mean, resource is just like a get request of what you can say, HTTP is request response structure. Uh, Prompts, if you see, so prompts are customizable units. So, I mean, yeah, this is a certain template which I have created. So it will return simply on the basis of whatever formatting you are trying to do. On the basis of that, it will populate this prompt and it will return to you. So this is pretty much it. And then we run the server, we specify the transport. So transport will be exploring more in coming videos. So here I'm using streamable HTTP. It will create a, what you say, a UVCon server type of thing so that the client can request it and get the response back. One more mode is stdio. Stdio mode, what it does is it will run a set of commands, whichever you specify, to start the server in the background. So that server will be running locally, but if your transport mode is streamable HTTP, you can host it anywhere. You can get that IP address and then you can connect to it. So let's just run the server. Uh, so my server is now running on localhost 8000. So by default, it's running on 8000 that you can configure using settings or .env file. One more thing, it's not configurable via UVCon. So if you run UVCon and you think that inside it you will give a port setting, so that's not configurable via that. You have to create a .env file so that this particular MCP SDK picks up that port. So now since our server is running, let's just, this is a simple client file which I've created. So in client file, we won't be using this particular structure. This is just to show that how JSON RPC format is used under the hood. By using SDK, there are like wrappers and there are abstraction of all these requests. So it becomes pretty much easy when you use SDK, but this I'm using so as to show where the JSON RPC comes into picture. So this is your initialization request of a JSON RPC. So whenever you want to start a conversation with the server, you want to tell that this is the client and I am connecting to you. So you have to give it something. The first thing is JSON RPC version which you are using. Then you have an request ID. Then you have the method, and then you have parameter. So you also have to tell the server what is your client ID and then which client you are, so that server knows where to send the data. So that sort of thing. It's kind of initialization request. So this is your initialization request payload. So protocol version, what are the capabilities? Capabilities mean what you can read, what you can write. So client, and these are basic low level stuff. So we won't be using this. I'm saying it again. We will be using MCP SDK. So these all things become irrelevant over there. I mean, inside the hood, if you see their core library, they are doing the same thing, but they just abstract it out in form of functions and wrappers. So for to initialize the notification, we make this request. So I mean, we can send the method name could be notification slash initialize. So if you're trying to access, if you're trying to list all the tools that are available with MCP, this method becomes something like list slash tools. If you're trying to list all the resources, it becomes like list slash resources. So something like that. So to list the tools, you can simply do tools slash list and it will list it out. So yeah, I think that's pretty much it about what do you say, JSON RPC. And now we can just simply run the client and see what's it's happening in the back. Okay, so I ran the command and you can see it found 5 tools. Uh, just so my client found out 5 tools that are running in the server. So get current time, and then you can see the description coming out of it. uh, what are argument then there is a calculate tool. Calculate description is it calculate mathematical expressions. What are the input it is taking, what are the output it is giving. So these all functionalities are coming out from that particular definition whatever we have written in the decorator of MCP tool. And then it found 3 resources, it found 2 prompts. So that's how basic connection work. And you can see that if I check my server, so it is receiving a request over here. And in the client also, you can see that there might be some place, yeah. So you have a server URL. So slash MCP, whenever you're using streamable HTTP, we use slash MCP as the endpoint. So this is the default endpoint where the streamable HTTP server runs. You can change it, of course. It's there, that particular transport you can change. By default, if you're using server sent events mode, I mean SSE mode, so for that the default endpoint is your I mean your IP colon port, and then you can simply say SSE. So these things we have to keep in mind while creating, because it will be important, because if you don't specify the current endpoint, the server won't receive your request and your code won't work. So that's pretty much the basics of how to connect with an MCP agent. Now, one more thing which I would want to show over here is the chat functionality. So what you can have your model. So I mean something like what you can say something like this. So what it is trying to do, it is using the OpenAI chat completion API endpoint. So where you can specify which model you want, I mean which agent, and then in tools you can give all those set of tools which are coming from list tools. So if the user gives any query to particular response, I mean for example to chat, if you provide any message, for example, if I ask a query, what is the weather in Tokyo? So this particular model, let's say Gemini model, will have a list of tools which we show, the 5 tools. And on the basis of query, like what is the current weather in Tokyo, it will figure out that, yeah, to answer this particular query, I can use the get current weather of a place tool. It will automatically figure out what arguments it need to provide based on the description that is coming from our MCP server. And it will call the tool. The MCP server will respond with certain data. And this model will know that, okay, I have to receive the data in this particular format. So model knows what input is coming, what input it is going to send to server, what output the server is going to send, all because MCP provides you a standard way. So that's where standardization comes into picture. So it becomes easier for model to decode that particular output which server is sending, and then on the basis of that, it can create your responses, and it can it can enrich your response on basis of the data whatever it is receiving from your MCP server. So that's how you can implement a chat functionality. You can chat, you can provide the tools and all. So that's pretty much it from the code side. This is simple demo, like it doesn't have any relevance with whatever we will be building. It's just to show how everything works under the hood. So in the coming videos, we'll be creating a UI around it. I mean, not the same server. We'll be creating a UI around it, and then we'll tried to bring in a real world simulation where this tool calls to and fro. I mean, there can be multiple clients running over here, how they interact with each other, and how they can use the MCP functionality to tell, I mean, to perform a certain task which seems very hectic doing manually. So yeah, that's pretty much it about the MCP introduction point of view, and we'll see you around in the next video.